So it's been compressed, so it's at point A now. Originally it was at point O. So this is compressed, therefore is this X, which is unknown. And then it says the cart is set free, you let it go, and it's quickly accelerated by the spring, and leaves the spring at point O. The cart then goes up the steep hill to one at the speed at point B, and the height at point B is known. Then it says use your Superman or Superwoman abilities to determine the average acceleration experienced by the cart and the people in it during the launching phase. Launching phase is right here. So you gotta figure out the acceleration. So you say, okay, acceleration A is equal to change in V over T. But you say, wait a minute, T is not given. And I remember somebody in the test, doing the test said, hey, you didn't give us T, I can't do this problem. I said, well, obviously figure it out. Okay. You can't use this formula because T is not given, and you can't find out what T is, so go another route. Try this one. VF squared minus VI squared is equal to 2A change in X. If you can figure out what VF, what VI, and what X is, you can figure out what A is. VI, right here, is 0, of course. This thing starts from rest. So VI is already known. VF, right here, is not known. So try to figure that out. And then X, right here, not known, you gotta figure it out. So we gotta figure out what VF is and what X is, because we already know what VI is. If we can figure out what those two are, we are done. So then, again, you may not know that at the time. You say, well, I don't know what I'm doing, but I know how to do something. There's no friction. So that seems to indicate I can use that MEA equals to MEO equals to MEB, because no friction. Some people did that. They wrote that, and maybe they got half a point for that. I don't know. That's something. Do something, at least try. Then MEA, you realize MEA, that's only 1/2 of kx squared. Because at point A, there's no speed. Of course, there's no height. It's all P elastic. At point O, it's all about Ke, because P elastic is 0 here, and of course, there's no height. So this is 1/2 of M times VB squared. And then, of course, MEB, that's all about PEG, because there's no more speed here. Of course, there's no more springs you can talk about. This is mg times hb. Some people wrote that and got, I think, a full point for writing that. Okay. And then they started plugging in numbers. Say, okay, well, what can I do here? You know that the mass is 800, g is 10, of course, and hb is 300. So when you do that, you get, where is my calculator? I think it's 2, 4, 5 zeros. Yeah. 2, 4, 1, 2, 3, 4, 5 zeros. That's the amount of joules. So that's ME everywhere. Okay. So then somebody got that and said, wait a minute, that means that this is equal to that, and this is equal to that. So they said, oh, 1/2 kx squared is equal to 24 with 5 zeros. So they said, oh, I can solve for x because I know what k is. K is given. When you do that, you get x equal to 6.20 meters. Some people did that. They got 2 points. They didn't know what else to do with it, but they did something that's positive, 2 points. Then they said, some other people said, wait a minute, I can figure out what VB is, or VO is. What do I write V here? VO. V at point O right here. Because VB is 0, of course. So then it's 1/2 of MV0 squared is equal to 2400000. You know what the mass is. You can solve for VO. You get VO equals to 77.46 meters per second. Some people did that. So they got 2 points for that, 2 points for that. And I think if they did all of this, they got 5 points for this entire thing. I think. I forgot. But anyway. And then some people stopped this and I don't know what else to do, which is fine. You did something, you got some free points. But then Josh and Eli actually, but Eli, he went too far, so that's why he lost points, because he had the answer, but he kept going. And he didn't know he had the answer. But Josh knew what he was doing. He said, oh, wait a minute, I have this and I have that. That means I'm done. Because VF, speed right here, that's 77.46. I square it, minus 0 squared is equal to 2a times 6.20. And obviously you solve very easily here. You get acceleration is equal to some unrealistic number, which wasn't my goal, but I couldn't get the numbers to make something that makes sense. But the number is 438.88, which is, if that was in reality, everybody would have died. That's way too much for the human body. But whatever. That's the answer. So definitely a tough problem. Not impossible, but definitely partial credit was there waiting for you, for those who tried something.
That's all.
You're right there. Yeah. I was surprised. You were right there. All right. So if I don't have any mistakes in your test, please bring it back.
weird.
And everyone gave me the test before, right? The other test? The previous ones? Yes.
I don't like hearing each other. I'm just like wondering, is it VFY going down?
BFY is right here.
Yeah, so it's going down. It's
Yeah.
going negative.
No, but the thing is, VFY doesn't come out to be negative. VFY is positive here, and that comes out as a speed, and then you can say that VFY is negative. So when you put negative here, from this step to this step, it doesn't make any sense.
Because the square root of something is positive or negative.
No. Well, every time we do the square root, it's always positive. So then the next step is put negative. That's why. But that's not why. Is that why? Yeah, I guess that's why.
Because like in math, we learn the square root of something, you always have to put positive and negative. So I just.
But we never do that, so that's why. But if that was the difference between a different grade, of course, but it wasn't. So. All right. So now we are moving on to chapter 7. So time to take out your notes. Chapter 7. The title is Circular Motion and Gravitation. We're going to be talking about initially about circular motion. We'll get to gravitation part a little bit later. But that's definitely the next topic on the test. And just so you know, I've been teaching this stuff since '04, and this is always the worst test of the year. Just so you know. Typically, I give about 7 to 8 Fs on this test. So don't be the one to get an F. Just let me know.
Oh.
All right. So, circular motion, gravitation, talk about circular motion. So circular motion, we know that if you are going around a curve, even if your speed is constant, you're accelerating. We know about that because your direction is changing. So even though your speed may not change, if your direction changes just for a split second, if you just curve a little bit, you accelerated because obviously your direction is not the same. So it means velocity change. If velocity change, you accelerated. Now we know acceleration is changing v over t. We know how to do that. If the speed is changing, we know how to figure out what the acceleration is. We also know how to do it using this one. The vf squared, we just did it, minus vi squared is equal to 2a in x. So we know how to deal with acceleration when the speed is changing. But we don't know how to deal with it when the direction is changing. We just know that if we go around a curve, we are accelerating, but we don't know what numbers to use. We don't know what to do because if the speed is constant, what do we do here? Do we put speed minus speed, the same speed? But we do know that we accelerate. Okay? So we have to figure out how to deal with that. Okay? And for that, we're going to do an example, and I'll show you that. So let's do an example, talk about circular motion first. So let's say this is a merry-go-round. This is a top view. So you're in a helicopter or whatever, and you're seeing a merry-go-round from the top, which means force of gravity is into the board, normal force is coming out. Okay? So let's say this thing is rotating this way counterclockwise. You could be at the center, right here. I'm going to call this point O. You could be at point A, right here. You could be at point B, right here, or you could be at point C, which is at the edge, right here. Okay? And let's say that the RPMs, revolutions per minute, or rotation per minute, RPMs is equal to 10. So this thing goes around 10 times per minute. 10 revolutions, 10 rotations per minute. That's not really the unit that we use in physics. Generally, we use degrees per second or radians per second, but everybody understands RPM, so I'm just using that for this example. Okay. So 10 RPMs, so 10 revolutions per minute. Question number 1. Which point, if any, has the greatest RPM? Michael.
O.
Say again?
O.
O, okay. What do you say?
C.
C?
Oh,
Nicole?
no. Oh.
They're all the same.
Sorry,
All the same.
All the same?
Yeah, it's
Yeah,
all
all
Why?
the same.
Because it's all on the same wheel.
It's on the same wheel. So when you go around, they all go around. Once, twice, they all take the same amount of time to go around. So they all have the same rotational speed, the same RPMs. Okay? So be aware of that question right there. Now, which one would have the greatest speed, the greatest tangential speed?
C.
C, why is that?
Because it's farther away, but it's going around a greater distance.
There we go. So this one is covering this distance when it goes around once, whereas this one only does this one only does that, and of course 0 doesn't do anything. So 0.0 would have no tangential speed. So VT, that is tangential, I can't even say that word correctly, but tangential speed is VT. That's basically the speed, the outside speed, the tangent speed, okay? We all know what tangent means, so the tangent speed, the tangent velocity, that's that speed. So the further away you are from the axis, the more VT you have, because obviously you're covering more distance every single time you go around. So if you were a person and you wanted to have more fun on this ride, you would go further out to have more speed than further in. If you ever go on a merry-go-round, you'll see that the really small babies are close to the center because it's not really going that fast in terms of VT, and then the older people, well, not that older, but 4 or 5 years old or whatever, are going to be on the outer side because they're moving faster. Okay, so they have the same RPM but different VT. Okay, so now we know that since the direction is changing, that these people are accelerating. We know that. Okay. Now, if the speed was changing, let's say your RPM was increasing over time. Let's say you went from 10, 20, 30. So this thing was starting rotating faster and faster. You would say this thing's accelerating, but this thing's accelerating because of a change in speed. And now we would call that AT, tangential acceleration. And AT, which we're not going to be talking about too much, because that's basically similar to what we've been doing before. Tangential acceleration, that is caused by a change in speed. I can't spell today, acceleration. That is caused by a change in speed. So whenever the speed is changing, okay, you can call that tangential acceleration, which is very similar to this stuff here. That's just when the speed is changing, velocity is changing. Yes.
Is tangential whatever
Yeah.
speed, is it instantaneous?
That's a great question, yes. Okay, yep. And then we also know that if the direction is changing, that also will cause an acceleration. And we're going to call that centripetal acceleration. So we're going to call that AC, and this is where we're going to be living for the next 3 weeks, centripetal acceleration. That's what we're talking about, circular motion stuff here. So centripetal acceleration, that is caused by a change in direction. So for that one, speed does not change. It may change, but we don't care. This is whenever the direction is changing, that is creating a centripetal acceleration. When the speed is changing, that's creating a tangential acceleration. And we know about this stuff already from there. We just never called it that. Centripetal acceleration, that's definitely new. Yes.
So centripetal acceleration, would it be like if you're going straight and then you start like slipping?
You curve.
Okay.
And then this has a formula. AC is equal to V squared or VT squared over R. So it's equal to the tangential speed squared over the radius of curvature. Because if you curve, there must be some radius of curvature. Even though you may not go into a full circle, but if you curve, if you do this, well, this is part of a circle that has a radius. So, 1 second. So VT, of course, we know that's in meters per second. And radius, that's of course in meters. So if you notice, on top you're going to get meters squared over second squared because the whole thing is squared. And on bottom you get meters. So therefore you are left with meters per second squared, which is what we expect for acceleration. Yes?
Is centripetal acceleration only if it's going in a circle? Like what if you're turning left?
It's a circular path. It's not a full circle. Circular path, that's it.
But not if you're just turning left. Like straight.
Left is a circular path. If you go in a circular path, that is your AC. Simple formula, nothing complicated here. Okay, so now you can do number 1, 2, 3, 4, page 226.
Can I share? Wait, can I share this with you? a Pokemon off.
Does anyone know?
Which one?
1, 2, and 3.
On 226.
Unprepared.
Mine's in my
Unprepared.
locker.
Very unprepared.
I was looking.
Narc, work habits right here. Seriously, guys.
Which one are we going?
1, 2, 3.
Oh, sorry. I'm just gonna stay. Okay.
And I will send you an email later on, by the way, with your grade, your semester grade. You'll have it
Okay. Oh.
within 30 minutes of the end of class.
Would that be the radius or the diameter? The road.
The radius.
Okay.
So far. Is VT is just meters per second, right?
Is it a speed?
Yeah.
Two decimals.
Would you ever give a direction or
That's a good question. AC is always directed inward.
in what?
It's always directed inward.
So we don't have to say it?
No, you don't say it.
Okay.
As in AC, the direction of it is always inward, as in inside towards the middle of the circle. So you don't have to indicate that. Alright, so number one, we're looking for VT. So VT is square root of A times R, which is square root of 3 times 2.1, 2.51 meters per second. Number two, same thing, VT is square root of AR with, well, ACR, we're gonna keep as AC, which is square root of 250 times 0.5, so that's 11.18 meters per second. Number 3, we're looking for AC, so that formula is already right there. After a while, I will stop writing VT. I'll just write V because it's the same thing, but I know the book uses VT, but it's the same thing. This is V. It goes to 1.5 squared over 1.5, so obviously we get 1.5 meters per second squared. And for number 4, we're looking for the radius, so we rearrange the equation, we get V squared over AC, which is 30 squared over 15.4, 58.44 meters. Obviously, nothing complicated here, just making sure we know how to use the formula, but this is easy. Okay, can I move on?
Yes.
Yes? Alright, so now let's attack some real problems. Okay, so now we're going to see what we're going to do with this information. So, there's this ride, it's not at Magic Mountain, but it's at many amusement parks where you climb into the thing, and it's like a little prison, it looks, because it's like those little barriers. You get inside, close the thing, you put this little mini chain on you, which does nothing, and you just wait. And then the thing starts to rotate like that. And next thing you know, you're against the wall, you can't move your head. And the thing goes vertical. And yet, you're not falling, you don't fall, okay? And you're not even strapped. So let's see what happens with this ride. So, that's the ride right here. Gravity is straight
That's
down.
so scary.
Okay? So, we're going to analyze what's happening when you're, listen up.
Oh, okay.
We're going to see what's happening when you are at the top and when you are at the bottom. Okay?
Is that as if you're looking from the side?
No, yes. So gravity is pointing straight down. This is not a top view. So when you're at the bottom right here, what forces are acting on you?
Gravity.
Gravity is not a force.
Oh.
Force of gravity.
Force of
Force of
gravity.
gravity, yep.
And
What else?
FN.
FN, what direction?
Up.
FN is up. All right.
Oh, on the top, FN is down, and gravity.
How do you know FN is down?
Because.
It's not.
Yeah,
No,
isn't it
gravity's
down?
still
It's
down.
always down.
No, she said that. But she said FN is
FN
pointing
is
down.
down
Why is FN down?
because it's not going against gravity. Like it's going the same way as
There's
gravity.
But
nothing
why?
underneath you. It's on the top there.
Nothing underneath you. That's correct. What?
They're against the wall.
There you go. Because now the wall is basically, I mean, it's not easy to do, but let's see, where's the eraser? If this is you, the person, this is the wall right here. So the wall is preventing you from flying that way. Because if this thing is rotating this way, you would want to fly out this way because of inertia. So the wall better be here to prevent you from flying that. So that means you're pushing against the wall. Newton's third law says the wall pushes against you. So the wall is pushing you down. That's the normal force. So Fn happens to be down in this case. Okay?
That's why you don't fly out.
Exactly. If the wall is not there, if the wall caves or is not strong enough, you're going to fly out. Okay. So now, let's see. What's the next step with this? So now let's say that I tell you, oh yeah. So basically, so now we know that we are accelerating. We already knew that. Okay. And we knew that because we're accelerating because the direction is changing. We already knew that. So whenever we are accelerating, there's got to be a force acting on us, a net force. And we know about F net equals ma, of course. But now, we're not going to call this F net anymore. We're going to be calling this FC, which stands for centripetal force. And centripetal force, mistake number one is that people think that it's one force in particular. So they will make this picture and then add another one and say, oh, there's got to be an FC as well. No. FC is not a force in particular on its own. It's like F net. F net was a combination. FC is a combination. Instead of calling it F net, though, we call it FC because now we're in the circular world. But FC and F net are the same thing. Okay? So FC is not a force in particular. The same way that you never would have written F net on its own. F net was a combination. Same thing here. So now we're going to be using FC equals to MAC. This Newton's second law is just rewritten for the circular world. It's the same thing. F net FC, same thing. A and AC, same thing, of course. And mass is still there. Okay? And when we're going to be doing our problems, we're going to have to figure out what FC is. So we're going to have FC equals to whatever. This plus that, this minus that, equals to MAC. And then we have to solve. Same thing with F net X equals to FGX minus FK. F net Y was Fn minus FGY. Same kind of stuff here. But now the mistake, thing number 2 to know is that it's no longer about up or down. It's about inward versus outward forces. If the force is inward, it's a positive force. So write that down. And if the force is pointing outwards, it's a negative force. So again, we don't care about up, down, left, right anymore. We care about, is it inward, meaning toward the center of that circle. That means if it's inward, it's a positive force, because if you think about it, it's helping you stay in that circle. And if it's an outward force, it's a negative force because it's trying to get you out of that circle. Okay, that's it. So in these problems, Fg may become a positive force. We're so used to doing Fg equals to a negative force that's people make that mistake all the time. They're so used to that every time they see Fg, oh, it's a negative force. Not in these problems. Fg is negative down here, it's positive up here. And then Fn happens to be positive in both cases, but we're going to have problems with what happens with a negative force.
Why isn't FG also negative up there? Because it's down still.
It's my inward.
Oh, it's in.
It's inward.
So we're gonna have to do at the top. So at the top, we're gonna have Fc equals to Fg plus Fn. They are both inward forces equals to MAC. And at the bottom, we're gonna have that Fc is equal to Fn minus Fg, not because of up and down, because of inward, outward. And that's equal to MAC. So again, people make the mistake all the time about the F, always so used to Fg being a negative force. It's like, no, look at the problem. Always used to Fn being a positive force. Look at the problem. Always used to Fn being opposite Fg. Look at the problem. Okay? So so that's why this chapter is very difficult, because you're so used to doing stuff for basically the last 4 months in one way, and all of a sudden now it's different. And you gotta basically deal with that. So let's say that I tell you that the radius of this is 12 meters. And let's say that the speed here is constant around this thing. So it doesn't go faster up and then faster or whatever. And let's just say that the tangential speed, Vt, is 18 meters per second. Okay? It does not go faster as you go down or whatever. Just constant RPMs, constant Vt. So now with this information, knowing what V is, knowing what R is, you should be able to solve for what Fn is and what Fn is here, as long as I give you the mass. The mass of an average person, of an average man, 80 kilograms. That's like 178 pounds. So I gave you the speed, I gave you the radius of this circle here, I give you the mass. You should be able to solve for what Fn is at the bottom and what Fn is at the top. So do that.
So when you make these rides, they do this on an average person? What if you're like,
They tend to do that, but obviously that's why some rides, if you're really too heavy, they may say you can't go on. And if you're too small, same thing, because you may get crushed by the acceleration.
that's nice.
So G's still negative 10.
Never
though.
seen that.
G
Is
has
all
never been negative 10, so
Negative 10. Yeah, don't know.
G has never been negative 10. What is G equal to?
10.
10. I mean, not yeah. Not negative 10. I was thinking A. Never mind.
And this is a classic problem on a test. Right now it's kind of difficult, but if I put this on a test in 3 weeks, you would think this is easy. But it's kind of medium, but definitely gets a lot harder than this. So this is but this is a potential test problem. The other one was way too easy. This is getting to the level of difficulty that we're trying to get to, but we're not quite there.
This would be like a medium.
This would be easy, I would say, in 3 weeks. Right now it's medium, but in 3 weeks this would be easy. I probably would not give that, but who knows? We'll see.
I'm
Mhm.
trying to visualize. FG is equal to both of them.
Yeah.
So Fn is equal as well, right?
No.
Eyebrow raise. I get a yes.
Look at the formula. Why don't you just solve the formula? I'm trying to take a shortcut. got them both?
Yeah.
What'd you get for the top?
1360 newtons.
Yeah.
Say it again.
1360
Units?
newtons.
All right. And then down here,
2960 newtons.
2960?
Yeah.
All right. Everybody get this?
Yeah.
Okay. So,
Wait, sorry, can you explain that?
Let's see. That's not hard.
Okay, I understand.
I really did that.
okay. So then we realize that Fn is greater down here than up here. If you've ever been on this ride in real life, you must have felt heavier down here than up here. Okay, you feel like almost a little crushed down here, and up here you feel lighter. Because we don't really feel what Fg is doing to us. We feel what Fn is doing to us. When you jump out of a plane, if you ever skydive, you're in free fall. But you don't feel your weight, you feel weightless. That's because there's no Fn acting on you. You don't feel your Fg. You feel your Fg whenever there is an Fn countering that, and now you feel your weight. So when you're standing still or walking around on the ground, Fn is countering your weight. If your weight is 100 newtons, you feel your Fn is 100, you feel your normal weight. If you are in an elevator accelerating upwards, Fn is going to be a bigger number, so that you have an Fnet that's up. Fn might be 200. You feel heavier because Fn has increased. If the elevator accelerates downwards, so now Fn is going to be a smaller number, so that overall you can have a downward acceleration. Fn might only be 50. You're going to feel lighter. If the cable breaks somehow, okay, cable breaks, you're in free fall. Fn drops to 0, you feel weightless again. So you feel whatever Fn is doing to you. So we see that our real weight is supposed to be 800, okay? Down here, we feel way heavier. We feel crushed. That's why when they make these rides, they have to worry about these things, because if this is too much, we can physically get crushed. It's like something is pushing you with that amount of force, we can't withstand that. And then up here, we feel a little bit less. We still feel heavier, but not as heavy as down here. Question.
Is that why on like airplanes, like when you're going up, you like feel really heavy?
I keep getting the same answers with an extra 0 at the end. I don't know what.
I don't understand how that's possible. It's written on the board. All you gotta do is put in calculator and press equal. So I don't know.
Okay, it's fine.
Okay, so now let's move on to a real problem that could be on the test. But this is definitely getting there. Understanding that Fn is not always the same, and that depending on how strong Fn is, we may feel more or less heavy. Because Fn is what we feel. We don't really feel Fg. Okay. Are you sure you have the negative here and the plus here?
Yeah, I found it.
Okay. So now we're gonna do a typical roller coaster problem. And anybody who's ever done physics with me just knows I do roller coaster stuff, because that's something I'm big on, roller coaster physics, because I feel like it involves a lot of topics, and it's like that. So let's say I have a roller coaster right here. I start from some height. I would give you that VA here is 5 meters per second. I would give you that this height here is, let's say, 200 meters. I would tell you that the bottom of this loop, which is based at this minimum distance here, it doesn't look that great, but at h equals 0, we enter this loop. So here we're upright, and then this is point B. And then when we're at point C here, we're going to be upside down. Okay. So point C is here, so we enter this loop, and we go upside down, and we're going to exit this loop and go over there. So this would be the beginning of a problem, where basically I could guide you, or I could just say, figure out Fn at point C and B. But if I guide you, I would say figure out VB first, figure out VC, and I will give you this radius, of course, as 85 meters. I can give you that. And then once you have VB and VC, I would say, tell me what AC is at point B, tell me what AC is at point C, and then I would say, what is Fn at point C, what is Fn at point B? And that would be the completion for these points. Now, I would not give you the mass until I ask you about Fn, because you don't need the mass to solve this initial part. This is basically like we did on the test. You can figure out what VB and VC is easily, as long as you know there's no friction. And of course, in this problem, no friction. And you have to use MEA stuff, and that's why I like this stuff, because this stuff includes stuff in the first semester still. So you can't just forget everything you just learned. Okay. So, first step, figure out what VB is, figure out what VC is. And when you have those, figure out what AC is down here, figure out what AC is up there. And then once you have those numbers, then I'll give you the mass to figure out what Fn is. Yes?
Is that supposed to be a circle?
Yeah. It's not perfect drawing, but yes,
No,
circle. So there we go. Figure out VB, figure out VC. Mass is not needed, and you should know that. And these first, good questions, of course. And this is a classic test problem. This is going to be on the test. This is guaranteed. There will be a big roller coaster problem on the test.
And then is beyond the ground.
Be on the ground, yeah. Even though my picture's not perfect, but be on the ground. On the test, I wouldn't put it on the ground, just to make it more difficult. And some of you guys who didn't do well this first semester, you have a time, now you have an opportunity to start fresh. Everybody starts from zero right now, so you can have a great second semester. And the reason why we're doing all this stuff today is because I will not be here next week, because I'm one of the chaperones accompanying the students to Israel. So.
How did that happen?
I don't know. They asked me to do it, but.
Wait, so what are we doing next week?
Mr. Perkins is supposed to start this class and the first class, the first block, and basically just do some more Central 4 stuff. I don't know how difficult it's going to get, because I don't know what I'm going to ask him to do, but basically do some stuff, keep you guys involved with it, and then when I come back, I'll deal with it. So that will be it. But I will probably send you an email or something like that to do some stuff. I'm sure I'll come up with something. So let me check your emails.
Do you at least get to chill at Israel or do you go
Oh, yeah.
straight to the airport?
I'll have the next weekend to do whatever.
Can we go to the Dead Sea?
Where?
The Dead Sea?
I don't even know.
Go to the Dead Sea?
You don't know.
I mean, I know about Dead Sea, but I didn't know, is it right there?
It's in
It's
Israel.
Oh, see, I didn't know that.
You should go to that to help her out.
You should go to Jerusalem, just because.
See, I don't think I'm gonna do. I think my itinerary is to go to the wherever the camp is, and then after that, I got a hotel in Tel Aviv. And
That's
after
right.
that,
Tel Aviv is great.
that's my plan.
Tel Aviv is like a mixture of New York and LA. But the first time I went to Tel Aviv,
Is point C at the top?
Yes, point C is at the peak of this loop, upside down.
Is it 200 meters? Like,
How's it
Wait.
200 meters?
well, like when I say top, I mean like.
For
at the start.
VB, do you need mass?
Oh, I see. Okay.
For VB, do you need mass? You don't.
No.
The velocity.
Did anyone get VB yet?
63.44.
I don't know, it's just a lot for reason. It's the name of the voice program.
What'd you get for AC?
The best one. The one that wasn't free. The one that's the
Narc. Is the box at point C at the same height as point A? No.
You're gonna figure out the height.
This one was
Oh. Oh, I'm stupid. Oh, it's perfect circle.
How do you just cross out M? Do you just like cross it?
Wow.
There's supposed to be an M here.
Oh, right. So then you cross them.
Is VC? I don't know how to ask. Is VC? VC?
Yeah. That's what I'm saying. I'm not even gonna say VT anymore. It's just the speed.
Okay.
It's just they're just trying to let you know that it's not rotational speed, so it's not RPMs. It's just regular meters per second.
Would you ever give us friction with this?
If I give you friction, can you do MEA as conserved?
Oh no.
Right.
63.
Yeah.
How do we spell that?
Do we need to know the height of the loop? The height of it. Ah,
Is VC 25 meters per second?
Mm-hmm.
Can I get the mass to solve for
Hold
FA?
on, I'll give it to you in a second. Let me just slow down so people can get a chance.
What do you have for VC?
25. VC?
Sorry.
VC is 25.
Oh, wait, 25.
Wait, I got the same thing. Oh.
All right. So there's no friction, so what that means we know we can do MEA equals to MEB equals to MEC equals to ME wherever because there's no friction. So you can figure out what MEA is. That's of course 1/2 of MVA squared plus mg times HA. So that's 1/2 of m times 5 squared plus m times 10 times 200. When you do that, you get 2012.5 times m. M is still there. So then you want to solve for MEB, for VB stuff. So you're going to say that MEB is equal to, which of course is going to be 1/2 of MVB squared plus MGHB, but that's basically 0 because that's the ground, so that goes away. But you know that MEB is equal to MEA. So that means that this 1/2 of MVB squared is equal to 2012.5 times M.
Do you have to write like MEA equals MEB? Well, when to write MEA equals MEB, do you have to write equals MEC?
No,
Okay.
but you gotta write there's no friction.
Yeah.
So then, obviously the masses cancel. That's why when you go on a ride like this, they don't really ask you what's your weight, okay? So what's your mass, I should say, not weight. So then you solve it for VB, you just do some math here, you get that VB is equal to 63.44?
Yeah.
0.44 meters per second. And that's some stuff you would have done. If it was on the final, you would have done that no problem. Okay. Then VC is the same concept. It's just a little bit hard, I would say, just because now there's a height. The height, of course, this is not a perfect, I didn't draw this right. But this is the perfect circle. If it's the perfect circle, 85 plus 85 is 170. So you would do that MEC is equal to 1/2 of M times VC squared plus mass times 10 times 170, which is the height there. But that whole thing is equal to 2012.5 times M, because that's MEA. So then when you solve here, you get 1/2 of M VC squared plus 1,700 times M equals to 2012.5 times M. Putting this on the right side, so 1/2 of M VC squared is equal to this minus that, which is 312.5 times M. Then you realize the M's cancel, so that's gone. So then multiply by 2 square root, so VC is equal to 25 meters per second. It looks right because it's less than VB. Okay, you pick up speed, and then you slow down, so it looks right. Because if you get something like 75, like wait a minute, why am I going faster as I go up? That doesn't make any sense. So be aware of those little mistakes. And also, if you get something less than 5, that wouldn't make sense either. If you get like something like 3, this is not as high as point A. So you should be going faster because you're lower. So just be aware of those little things where you can check your mistakes. And then get an AC down here. That is just going to be the speed down here, which is 63.44 squared over the radius, which is 85. And this gets you 40 something?
47.35.
47.35 units.
Meters per second
Meters
squared.
per second squared. So that's about 4.7 Gs. So that's actually quite realistic. I mean, that's definitely a big acceleration, but it's not like lethal because humans can withstand between 0 and 9, I think, something like that. 9 is like if you're like a pilot or a space or an astronaut. And then up here, AC is going to be the speed up here, so that's 25 squared over 85, and that will get you
7.35.
7.35, and that's less than 1G, so that's definitely no problem. Per second squared. So that's definitely, that would be like a test right there. Okay, and then the next step would be figure out what Fn is down here and what Fn is up here. Okay, so that means you would have to make the picture. You would say, okay, well I know that up here Fn is pointing down and Fg is pointing down. Up here, down here Fn is pointing up, Fg is pointing down. Okay, and now at this point you need the mass. You can't figure out Fn if you don't know the mass. Okay, so I would tell you for like this would be probably question D because you would have done A, B speeds, A and C, so that's like A, B, C, D. So these problems, it's like A, B, C, D, E, F, G. Like it's a lot of steps, but it's really not that hard. But still, there's a lot of stuff going on here. So anyway, if I erase this stuff to make some room, let's say I give you that the mass is 200 kilograms. Okay, then you can figure out what the Fn is at the top and what Fn is at the bottom. And since I want to be equal with the other classes, you don't have to do it right now. You can do it as homework. Okay. Homework is to read section 1 of chapter 7. Okay, and finish this problem. Figure out what Fn at the top and Fn at the bottom. One of those Fn's is going to be weird. We'll talk about that when I come back, or maybe through email or whatever. So definitely be checking your emails next week because I'm sure I will communicate via email at some point. So you don't have to do it right now. If you want to, you can, of course, but otherwise you can go. Because this is what I ended with the other class.
What are the pages for the reading?
I don't know. Section 1, chapter 7.
Chapter 7.
Yeah.